All right, for the first part of class today, what I want you to do is just work through page 1 on the lesson. It's just a review of topic 1, which was Intro to Rational Functions. So what I want you to do here is pause the video, work through this to the best of your ability, and then come back and I will go over it. So going over this, the first thing you want to do is factor the numerator and the denominator. Numerator is difference of two perfect squares. Denominator, x plus 2, x plus 1. So for a deleted point, you're going to take your shared factor, set that equal to 0 and solve. You get x equals -2. And then you're going to substitute that -2 back into the simplified function to get the corresponding y value, in this case of 4. So you have a deleted point at -2, positive 4. X-intercepts means y is equal to 0. So you're just going to set y equal to 0 in this simplified function. So 0 is equal to x plus 2. The reason I didn't show the x plus 1, if you want to, it's going to be divided by x plus 1 equals 0. But when you multiply both sides by x plus 1, you're going to get 0. So you're just going to get that. So in essence, you're setting your numerator equal to 0 and solving, you get 2. So the x-intercept is 2, 0. For a y-intercept, x is equal to 0. So take your simplified function and plug in 0 for x, and you get y is -. So the y-intercept is 0, -2. Vertical asymptotes. You're going to take your simplified denominator and set that equal to 0 and solve. When you do that, you're going to get x equals -1. Horizontal asymptote. You're going to go back to the original. The degree of the numerator and the denominator are the same. They're both 2. So you're going to divide those lead coefficients, in this case 1 and 1, and get y equals 1 for the horizontal asymptote. Oblique or slant asymptotes, you don't have any because the degrees are the same. Only time you do is if the degree of the numerator is 1 more than the degree of the denominator. So none. Coordinates where the graph crosses the horizontal asymptote, if any. So what you're going to do, you're going to take your simplified function and set it equal to the value of the horizontal asymptote. You're just going to plug in y is 1. So 1 is equal to this. Multiply both sides by x plus 1. Those simplify to 0. To 1. You're left with x plus 1 equals x minus 2. Subtract x. 1 is equal to -2. That is not true. So this graph does not cross the horizontal axis. And for domain, we're looking for all values where the denominator was equal to 0. So you're going to take your original denominator, not the simplified, and set those factors equal to 0 and solve. And you're going to get all real numbers except -2 and -1. All real numbers except -2 and -1. If you prefer to write this in interval notation, it would be -infinity to -2 in union with -2 to -1 in union with -1 to positive infinity. Okay, so that's going over the initial part. Okay, we're going to take a look at one of these questions here together. And then the others I'm going to have you work through on your own and go over those answers. So the only new learning target is I can sketch the comprehensive graph. So looking at the actual graph while still getting all of this information. So we're going to be working on that same concept that we did last class. So as we did last class, we're going to, and on the do now, you're going to factor the numerator and the denominator and simplify if possible. There is nothing to simplify, so that's it. So coordinates of any deleted point. Excuse me. Oh my goodness. There's none. We don't have any shared factors, so there's none. X-intercepts means y is equal to 0. So y is 0, so I'm going to take this, 0 equal to x plus 3 times x minus 3 divided by x plus 5. If you multiply both sides by x plus 5, this is going to simplify to 1. Doing it here, 0 times anything is 0. So you're going to be left with 0 equals x plus 3 times x minus 3. You set those equal to 0 and solve, you get negative 3 and positive 3. So those are your x-intercepts. Number 3, your y-intercepts means x is equal to 0. So now we're looking for a y value. We're going to plug in 0 for all the x's. 0 plus 3 times 0 minus 3 divided by 0 plus 5. 3 times negative 3 is negative 9 divided by 5. That's your y-intercept. Vertical asymptotes, set your denominator, your simplified denominator equal to 0 and solve. It's just that x plus 5 equal to 0 and solve. Horizontal asymptotes, the degree of the numerator, 2 is bigger than the degree of the denominator, 1, so there's none. Number 6, slant asymptotes or oblique. There is a slant asymptote because the degree of the numerator is 1 more, exactly 1 more than the degree of the denominator. So we're going to set up division with the x plus 5. And on the diagonals, x squared, 0x, we do need a placeholder, minus 9. Starting at the top left, x squared, x times x is x squared. That's a 5x. If these add up to 0, this needs to be a negative 5x. So that's going to be a minus 5, minus 25. We don't care about the remainder. We're going to disregard that. This is the slant asymptote, y equals x minus 5. Number 7, there's going to be none. There was no horizontal asymptote, so we can't cross it. And number 8 for the domain, it's going to be all real numbers except x equaling negative 5. We're just going to set that entire domain equal to 0 and solve all real numbers except x equals negative 5. So just filling this in on the bottom, no deleted points, x-intercepts are negative 3, 0, and positive 3, 0. Y-intercepts are 0, negative 9/5. Vertical asymptote, x equals negative 5. Horizontal is none. Oblique, y equals x minus 5. Nothing for number 7. So 5 and 7 are none. None. And the domain, all real numbers except x equaling negative 5. All right, then we want to graph this. All right, so we're going to take this and put some axes on here for your x and your y axes. When I'm grading your comprehensive graphs, I'm looking for this information to be accurate. So x-intercepts, negative 3, 0, positive 3, 0. Y-intercept, 0, negative 9/5. The decimal equivalent of that is negative 1.8. There's a vertical asymptote at x equals negative 5. So we're going to put a dashed line there. And there's a slant asymptote at y equals x minus 5. So the y-intercept here is negative 5. So I'm going to go down to negative 5 on the y-axis. The slope is positive 1 divided by 1. So I'm going to go up 1 to the right 1, up 1 to the right 1 a few times. And I'm going to graph this slant asymptote. Okay, so that's what the graph looks like so far. So now we're going to utilize the calculator to figure out what the actual behavior is as it approaches these asymptotes. So just a reminder, you can get to the shortcut by doing alpha y equals to get the fraction. So there's the fraction that we have. I'm going to graph that. And I can see the one piece of the function, but the other piece of the function is down here to the bottom left. So what I really need to do is change this window. I need to go further to the left, let's say negative 20, and further down, say negative 30. And now I can see that second piece of the function. Okay, there's your negative 5. That's that vertical asymptote. Here's that slant asymptote that you see of x minus 5. So when I'm graphing this, there's not a ton of room here, but essentially this graph is going to do something like that. That's a little aggressive. Let's kind of scale that back. Okay. And then this graph piece, it's got to go through these 3 points. Make sure this is nice, clean, accurate, that the graph is approaching the asymptotes but not crossing, and that you have both parts. It's got to go through the x-intercept and the y-intercept. So what I would like for you to do is pause the video and work through page 3 and page 4.